I know I look different. Still me. This is going to be lesson 4, unit 7, scientific notation. We're going to dive right into it. So, first of all, what is scientific notation? Well, so these numbers on the left are in standard form, and the numbers on the right are those same numbers in scientific notation. So, we're going to look at some examples in a minute, converting between the two, and it's really pretty straightforward, not very hard at all. And which is why I've never understood why teachers like teach kids to do it like using the calculator, because honestly that takes more time. Anyway, I'll show you. It's really easy. It's easy peasy. If you've never done it before, it's not hard at all. I gotcha. So scientific notation is the number with a decimal right after the first thing and then times 10 to some power. So you can see that we multiply 554 times, or excuse me, if we multiply 5.54 times 10 squared, or 100, then it's going to move that decimal place over and we get this original number. So the same idea with all these numbers. And on a negative number, if we start out with something that's smaller than 1, then we multiply times a negative number, and you're going to move the decimal place the other way, right? And same idea here. This time we multiply times the negative 10 to the negative 3 and move the decimal place over 1, 2, 3 times, and we get the original number, you know. And so the question that may be in your mind right now is why? Why do we have standard form and scientific notation? Is that just like math teachers trying to be obnoxiously difficult and making life annoying? No, it's not. And it's real simple why we use why scientific notation exists. It exists because of in science, we often deal with really, really big numbers or really, really small numbers, right? And so things like Avogadro's number and whatever are examples of that, where you have a number that's really large, and if you were to write it out in standard form, it would look really big, or it's really small, and it would also look really big because it'd be 0.0000000002587654321, right? Whatever else. So either way, you have to write out a whole bunch of mess, in standard form to be able to represent that number. So we use scientific notation to be able to do that with larger numbers and smaller numbers. Now, when we're learning it, we practice with numbers that are not that hard to do, just because that's a good way to practice and learn the concept. So let's dive in and look at some examples. All right, so first couple of examples is we've got these guys in standard form, and we are supposed to express them in scientific notation. So it's really easy to do that. Whenever we start with something in standard form, the first step to turn it into scientific notation is to find where the decimal place is. So if we're looking at this number, where is the decimal place? Well, I don't see one, right? So if I don't see one, where is it? Well, he's here, right? There's where the decimal place is. All right, and then what I do is we bounce our way over until we are just to the right of the first non-zero number, right? So the first non-zero number, and that's expressing it that way is more helpful when we're looking at an example like this, maybe, than this one. So we're in correct scientific notation, the decimal place goes to the right of the first non-zero number. So that's how far we're bouncing. So we bounce, and then we bounce 1, 2, 3, 4, 5, 6, 7, 8 times. So then we just have to write it out as 2.01. Now, you notice I didn't write all of these zeros. So after the last non-zero number, everything else just kind of disappears, right? Because we don't need it. So then we do times 10 to the, and how many times did we move over? We moved over 8 times. So 10 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we did. All right, so there it is. Easy peasy. So we do the same sort of thing over here. We start wherever the decimal place is. So we start right here. And then we're going to bounce 1, 2, 3, 4, 5. And so we're going to give our answer as 5.1 times 10 to the negative 1, 2, 3, 4, 5. So this time it was negative. Now, so you can think about that, about whether the exponent is going to be positive or whether it's going to be negative in a couple different ways. What most people teach is that if you bounce to the left, then you have a positive exponent. If you bounce to the right, you have a negative exponent. I find that way of thinking to be difficult to remember in the brain. Like it'll get confused and whatever, and then it translates into errors that really don't need to be there. And so what I find is a maybe better way to think about it is, did I start with a big number or a really little number? So big number, anything greater than 1, right? Or did I start with a little number, like something less than 1? If I start with a big number, positive exponent, because we want when we go back to standard form for our number to grow, right? If I start with a really little number, then it's a negative exponent because I want my number to get smaller, right? And so I find that to be an easier way to think about it. But either way, whether you think about the left or the right, left or right, or you think about big number or little number, that's how we know, one of those two ways. So let's do the other way. So we're going to express each number in standard form. So this one, if we're kind of following a step-by-step procedure essentially to do it, it's kind of has one extra step. So the one extra step is to write down the number, the original number, without the times 10 bit, right? So 6.32. Right? So just the number without the times 10 bit. And then you're going to bounce again, just like we did. So we've got a positive number, so we're expecting a large number, right? And so if we bounce this way, we're going to end up with a larger number. So we bounce 1, 2, 3, 4, 5, 6, 7, 8, 9. So our decimal place moved way over here. Now, what do we do with all this extra mess? Well, all of the empty bounces, empty bubbles, they get zeros added to them, right? We stick zeros in there. And then I like to, and I want you to as well, rewrite this number without all the ugly drawing stuff. So remember, these bounces are actually moving the decimal, so don't put the decimal in like both places or something weird, right? So 6, 3, 2, 0, 0, 0, 0, 0, 0, 0. So this is, what number is this? 6,320,000. You don't necessarily have to put the commas in your answer. I just did because it made it easier for me to tell you what that number was. So this guy, so we're going to do the same thing. We're going to start by writing the number without the times 10 bit. So now we're going to bounce the decimal. Now it's negative, so we're expecting a little number, right? So we're going to bounce it this way. So bounce once, twice, 3, 4, 5, 6, 7. My bounces look really ugly in that direction. It's okay. So then all of the empty places, we're going to have a 0. So 0, and then 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 another 0. Don't forget that we have a decimal place. Now, this is not really a number until we put a 0 right there, right? We don't like just doing point whatever. We want 0 point. That's what we want. So we're going to rewrite our answer without the ugly stuff. So 0.000000. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 with a 4. So this is 4 tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. 4 10 millionths. Great. Easy peasy. Let's do a couple more. Oh, ugly. Uglified. So this looks a little scary, right? It does. It's not scary, actually. And I will note that on problems like this, you could technically just chuck all this in your calculator. Now, I'm going to encourage you to not to do that. Because, and believe it or not, doing that is working harder instead of smarter. Because it's going to take longer to do that than, and to be prone to more errors of, like just accidentally typing something in wrong than doing what I'm going to tell you to do. So, and I'm going to actually show you all the steps. You could arguably kind of do the commutative property step in your head. But so this is all multiplication, every last bit of this. So the commutative property says we can rearrange it, right? So we could do this as 3.5 times 7 and then times 10 to the negative 3 times 10 to the 5th, right? So we just group the little 10s. Now look what we have here. Look what we have. We have like bases. They're multiplied. So what do we do with the exponents? We add them. So negative 3 plus 5 is 2. So this just turns into 10 squared. Now 3.5 times 7, you might could do that in your head. You definitely could do it on paper. But that we're gonna chuck that in the calculator because it sounds like a good plan, right? So 3.5 times 7, right, is 24.5. Now, the one thing here is this isn't technically correct scientific notation, right? Because remember, correct scientific notation, the decimal place should be right behind the first non-zero number. So I got to bounce this over one more time. So I got to bounce it over and turn this into 2.45 times 10 cubed, right? So I bounced this way. I made the number smaller. So in order to get back, we've got to get a bigger thing over here. So there's the scientific notation one. So then if I move the decimal place 1, 2, 3 times to get the standard notation one, I would have 245, 2,450, right? You could totally do that by hand. Just do 2.45, bounce 1, 2, 2, 3, 0, right? Bam. Let's do one more. Oh my gosh, keeps being crazy. All right, we're gonna do this one. This one looks even uglier, even scarier, but it's really just as easy. And so let's do it. So we got 3.066 times 10 to the 8th divided by 7.3 times 10 cubed. Like base and divided, what do we do with those exponents? We subtract them. So we're going to end up with times 10. 8 minus 3 is 5, so 10 to the 5th. This, we're going to check in the calculator. That one you could do by hand. That one will be pretty tricky to do in your head, but maybe some of you are better at that than me. I definitely think this one, at least, even if you're doing this one in your head, and you're like, I got this, I would double check it on the calculator just for sanity, right? So 0.42. So 0.42, right? So this is a small number, right? So we're subtracting, we're going down, right, to convert this back. I'm going to move that decimal place over once and turn it into 4.2 times 10 to the 4th, right? So we're getting littler, right? So we're doing that. So there's that. And then the what am I saying? The standard form. Sorry. The standard form version, we got 4.2. We're going to move it 1, 2, 3, 4. 1, 2, 3. So the standard form version is 42,000. Great. That's it. Done. That's all there is to it. Easy lesson. We'll see you in class or just in the comment section. Have a wonderful, wonderful day. Bye-bye.